Welcome to The Explainer. Today, we are tackling a scenario that absolutely strikes fear into the heart of every infrastructure engineer. We're going to transition your mindset from that reactive, panic-driven response during a total Kubernetes meltdown to a proactive, SRE-driven approach. We're going to look at what actually happens when your cluster collapses, how to methodically bring it back to life, and finally, how to design systems so incredibly resilient that you can intentionally destroy them just for practice. Picture this. It's 3 a.m., you get paged, you stumble to your laptop, open up Grafana, and your dashboard is just a sea of red. Everything is failing. You can't create new pods. Your trusty kube control CLI is completely disconnected and timing out. The dev team is blowing up your phone because all the CI/CD pipelines just tanked. And worse, your clients are getting massive spikes in 500 errors. Then the real alerts roll in. Kubernetes API server unreachable, etcd cluster quorum lost, control plane down. In that exact moment, your stomach drops, and you just think, it's over. Kubernetes is completely dead. But let's pause for a second and ask a really fundamental question. Can Kubernetes actually completely crash? We're so often taught that Kubernetes is this magical orchestration tool that's inherently highly available. A lot of engineers naturally just assume that because it manages containers so flawlessly, it simply won't go down. Well, to answer that, here is our tactical map for this explainer. First, the anatomy of a crash. 2, triage and why you should not reboot. 3, reviving the etcd brain. 4, complete control plane loss. 5, enterprise prevention architecture. And finally 6, the chaos crucible. All right, let's jump right into part 1. The anatomy of a crash. We really need to understand the fragility of the cluster here. Because before we can fix a broken cluster, we have to understand what makes it fragile in the first place. Kubernetes isn't some unkillable monolith. It's literally just a stack of interconnected services. You've got the control plane, the API server, etcd, the scheduler, the kubelet, your container runtime, your CNI, the list goes on. And a failure in literally any of these layers can paralyze the whole thing. Your etcd data could get corrupted, your certificates might expire, which completely paralyzes the kubelet's ability to authenticate. Or, hey, maybe someone accidentally deletes the master virtual machine. It happens. In the real world, the fatal crashes aren't just a couple of pods dying. It's the underlying control plane taking a hit. Which brings us to part 2, triage. Do not reboot. I repeat, do not reboot. Look, when the sirens are blaring, human instinct screams at you to just find a quick fix. You want to reboot the machine. You have to overwrite that instinct. Rebooting blindly destroys vital forensic evidence. Instead, you need to run through a methodical isolation checklist. Step 1, check the API server. Run kube cluster info. If it times out, you know your control plane is lost. Step 2, SSH directly into your master node and run systemctl status kubelet to see if it's healthy. Step 3, verify the actual API server container is running using Crictal PS. And step 4, confirm your etcd health by running etcd kelt endpoint health. If your terminal spits back unhealthy, well, you've just found your culprit. So let's talk about how to fix that in part 3, reviving the etcd brain and curing Kubernetes amnesia. If you found an unhealthy etcd, you are dealing with a central brain failure. etcd stores your entire cluster state, so a corrupted etcd means Kubernetes has effectively caught amnesia. This is wild, but when you type kubectl get pods and it says no resources found, your apps aren't necessarily dead. The API server literally just forgot where they live. So if you are in this terrifying scenario, you need your ultimate lifeline. First, you check your snapshot status. If you have a backup, you run ectctl snapshot restore to rebuild the ECT data, and then restart the kubelet. Mature environments are backing this up every single day or even every hour. Because listen to me carefully on this, if you do not have an ECD backup, you do not have a Kubernetes cluster anymore. It's gone. That backup is your absolute final line of defense. Now, let's escalate things in part 4, complete control plane loss. What happens when all your master nodes just vanish? Let's say your underlying VMware cluster has a catastrophic hardware failure. All 3 of your master nodes get wiped out. The control plane is completely gone. This actually highlights a fascinating quirk about how Kubernetes is built. The limbs are actually still alive, even when the brain is dead. Your applications, the literal containers on your worker nodes, are probably still executing perfectly fine. The catch is, you just have no way to manage them, update them, or route new traffic to them. It's basically a zombie cluster. To fix a zombie cluster, you have to do a surgical cluster resurrection. You are essentially grafting a brand new brain onto those surviving limbs. First, establish a new master node using kubeadn init. Step 2, do that life-saving etcd snapshot restore. Step 3, use kubeadm join to reintegrate the new control plane. Step 4, meticulously restore your CNI network like Calico or Cilium so everything can talk again. And finally, verify your nodes with kubectl get pods-a. Only then is your cluster officially resurrected. Okay, part 5, Enterprise Prevention Architecture. How do we design systems that just don't break in the first place? Fixing a broken cluster is an awesome adrenaline rush, but heroic 3 a.m. rescues are a terrible long-term strategy. Mature SRE teams focus on prevention. We're talking 5 distinct layers of high availability. Layer 1, an HA control plane with 3 or more masters to kill any single point of failure. Layer 2, an isolated etcd cluster of 3 or 5 nodes specifically to maintain strict quorum. Layer 3, automated hourly snapshots. Layer 4, pushing those backups off-site to S3 or an NAS, so if the whole data center burns down, your data survives. And Layer 5, the ultimate failsafe, active DR clusters, running a primary in Taipei and a secondary in Taichung, for instance. If the primary completely tanks, traffic just auto-switches to the secondary. The client never even notices. And finally, part 6, the chaos crucible, forging reliability through destruction. So, you've built this impenetrable 5-layer fortress. Great. How do you actually know it works? True reliability comes from intentional destruction. This is chaos engineering. Today, your team's drill might be to log in and literally delete a live masternode. Next week, maybe you shut down etcd completely in staging. Next month, simulate a massive data center power outage. The whole goal is to prove you can flawlessly execute the recovery when the adrenaline is pumping, rather than just relying on a disaster recovery doc setting on some wiki page. There's a famous philosophy from Google's SRE teams that perfectly sums this up. Hope is not a strategy. You can't just build a highly available architecture and hope it works when disaster strikes. You absolutely have to verify it. And that requires a massive mindset shift. Beginners learning Kubernetes are super focused on perfectly formatted YAML finds, deployments, and ingress controllers. But the SRE masters, the infrastructure architects, they operate on a completely different level. They are obsessed with disaster recovery, cluster resurrection, and hitting brutal recovery time objectives. All right, let's lock in the key takeaways from this explainer. First, the most fatal system-wide failures hit the control plane and etcd, not just the pods. Second, an automated off-site etcd backup is your ultimate insurance policy. Third, a dead control plane does not mean your workloads are dead. Fourth, proactive HA design is infinitely better than being good at post-crash fixes. And fifth, chaos engineering is literally the only valid way to verify your disaster recovery actually works. I'm going to leave you with this final provocative thought. When the cluster totally collapses, your clients absolutely do not care how elegant your YAML files are. Your boss is only going to ask you one thing: how long until we recover the service? So ask yourself right now, honestly, if your cluster went down today, do you actually know the answer? Think about that and start building your resilience today.